Hello all, welcome to another KenKen puzzle we're going to be solving. This puzzle comes from us from a website, joemauler.com. He said that it was one of the hardest KenKens he had ever had to solve, so I thought it'd be fun to take a look and see if we can't solve it. So let us begin and see where we go from here. So we can fill in the 5. We can fill in the 1. Awesome. We got a great progress so far. What could be so hard? One thing I immediately notice is basically everything is pluses across the board. So I can understand why we would consider this a very hard one. Without multiplication, there aren't a lot of easy, immediate moves like looking for 5s or 7s and looking for things that might be easier to actually limit down what what numbers could be in which boxes. One thing I do see though is that we have this guy, which we can see 15, 13, 7. The pluses really give us an easy way to be able to see, sort of fill up the columns and extrapolate. So if we know that this must equal 1 plus 6, 2 plus 5, 3 times 4, so each column and row will equal 7 times 3 equals 21. So therefore, this guy's got to equal 42. We also, though, know that this must equal whatever the difference is between 9 and 42. So it's going to be 42 plus some number, and that is going to equal this guy. So let's do that real quick. All right, so we have 1, 15, 13, 7, and 9, which gives us 26. Is that right? Yep, 26 and 9 is going to be 35. Am I doing that right? I screwed up somewhere. 20, 15, 9. So 20, 30, there we go. It's not 26, we have 36 plus 9 is going to equal 45. And like we said, 42 minus 45 is going to equal 3. So this right here is going to be 3. Let's erase all this stuff here. So we see that this is 3. So similarly, if we know this is 3, then this must be something. So 11 plus 10 plus 3, 10, 11, 21, 24, 10, 11, 21, 24. So if we have 24, one grid can be at most 21. So therefore, this number must be 3 again. So again, this is 3, 21, the whole thing is 24, therefore we subtract it and we got 3. All right. What do we do next? One thing I am noticing again is that we have this set of rows, and then we are left with these two. We're not going to be able to know exactly which number fills in with these, but at least we can find their total sum. So if we can say 1, 15, 10, 13, 11, these guys, we can basically do a similar thing. That's going to be 16, 23, 11, 27, 23, 50. 42 are our column times 2, therefore 8. So these two will equal 8 together. So I'm just going to note that equals 8, which obviously with 8 can't be 4 and 4 because they share a row. We can do 3 and 5 or 2 and 6. Just a thing for us to note, and so I'm actually just going to put, I'm just going to remember that. I'm kind of wondering just out loud, like, is there something we could solve for here? Or actually here? Because if we know that this is 21, and this is 13, let's just take a look at that. So if we say 3 plus 13 plus 3 plus 13 plus 11, that's going to be 16, 11, 27. We have 21, so this together just must equal 6. Doesn't totally help us, as there are a number of options up here. 6 can be equal, basically, it doesn't eliminate, so it doesn't really eliminate any numbers, but at least it lets us understand roughly what 6 is going to equal. So still haven't gotten a great solution here, but we're starting to make headway. So let's look next at 11. Because the 5 is already covered here, there are only 2 ways for us to make 11. 1, 4, 6, or 6, 3, 2. So we know then that 6 must be in this somewhere. But it also could be 1, 4, or 2, 3. Both of those are possibilities. If this is 1, 4, or 2, 3, therefore 1, 4, or 2, 3 over here must be one of these two. So we don't know exactly where they are. Just thinking here, let's think. If this is a 1, this would equal 12, which cannot be added together. With the max we can have is 11. So you really can say something, at least for this one, that if it is 1, 4, then 1 has to be over here, 4 has to be over here. 2 and 3, 2 is 11. So if it is 2, this would have to be 5 and 6. If this is 3, that's 10. It would have to be 4 and 6. And if this was 4, that's going to equal 9. 9 could then be 4, 5, or 3 and 6. So again, 4, 5, or 3 and 6. So we have 4 options here. That doesn't seem particularly helpful for any of this. Just something to note. If we look over here, we know this is 9, this is 5. Therefore, 21 minus 14, 21. Yeah, that actually 21, and then 9 plus 14 is 14. That leaves us with 7. So 7, obviously, there's nothing that's sort of eliminated. 6 plus 1 could work. 4 and 5, 3 and 6. We don't see a 2 here. I don't know if that really helps us. I'm not sure if that really helps us anywhere. One thing that's clear, this cannot be a 6, or else that would add up. So we know that 6 cannot live here. It has to live here. There's a bunch of 6s here, so that makes sense. Again, that doesn't particularly help us make headway here. This is interesting. So let's go back. If this is 6, this means it cannot be 3 plus 3. It can be 2 and 4 or 1 and 5. Obviously cannot be 1 and 5. Therefore, 2, 4. Two, 4. One thing here is that this is the first actual set of numbers that we know for a fact is 2 and 4. This could be 1 and 4, 2 and 3. This could be a million things. This could be 2 things. The other thing this helps us is that if this is 2, 4, this therefore must be 6 or 1. Again, this cannot be 1. So we can very confidently now say this must be 6 and this must be 1. Oops, wrong. Said that too fast. This must be 6. This must be 1. Therefore, 4, 5 is not available to us. But that gives us that. So if we know that this equals 6, and we know that this equals 6, and we know, I'm wondering, is there any way we could sort of come to some conclusion about these two numbers? So 21 minus 6 minus 6 minus, it's either 3, 4, 5 minus 3, 4, or 5. 21 minus 12, let's put over here, 21 minus 12 is going to be 9, which means, is that right? Yeah, 9, which means this is going to be 4, 5, or 6. So we know that this must equal 4, 5, or 6. 1, 6. 2, 5, 3, 4. Doesn't help us. Hello, Captain Obvious. Maybe it would have helped us. I don't know. This obviously equals 10. This equals 6. Then this must equal 7, and this must equal 10. Interesting. So if this equals 10 and this equals 7, just intuitively that makes sense. Seven is going to be 1 and 6, can't be. 2 and 5 definitely possible. 3 and 4 can't be. Oh, that's nice. 3 and 4 can't be. So it's got to be, this has to be 2 and 5. Awesome. So if this is 2 and 5, 3 and 1, this has to be 4 and 6. Huh. Of course it had to be 4 and 6. Couldn't be anything else. Just because 5, a 10 must be 4 and 6. But the 7 here, the 7's nice to note. 2 and 5, 3 and 4. All right. I wonder, can we figure out the 11? What might an 11 be that can't be a 3? Is there any numbers that would be nice? 6, 3, 2, not possible. 5, 6, 3, 2, 5, 4, 1, definitely possible. 3, can't be that. So this 6, 3, 1. Am I missing something? 5, 3. Nope. So this has to be 5, 4, 1. 5, 4, 1 leaves us with 6 and 1. Nope. What did I do wrong here? 5, 4, 1 is not. Can't be that. So let's do that one more time. So it can't be 3. So it can be 6, 4, 1, 5. Does it have to be 6, 4, 1? 6, 5, 6, 4, 6, 2. Yeah. It has to be 6, 4, 1, which leaves us with 5 and 2. That makes a little more sense. So now we have 5, 2, we have 6, 4, 1, and we have 3. 5 and 2, 5 and 2. This can't be 5. This could be 5. This has to be 5. Does this have to be 5? I'm not sure. This 7 is going to be difficult. Here's 4, 3. This is a 3. That can't be a 3. How did I get this 3? I don't actually think I know that. It has to be, it could be any of these. So this could be any. So that's not known. I think what I want to do, I'm going to pull out a different color. I'm going to say, let's assume that this is 2 and 4. Where can we go from here? So if this is 2 and 4, let's go up this way and take a look and see if we can't find a contradiction. The reason I'm doing this is 2 and 4, it's either one or the other. It's 2 and 4, it's 4 and 2. So if it's 2 and 4, we should be able to progress and find a contradiction somewhere and then move from there. So if this is 4, then 7, it has to be either 5, 2 or 6, 1. So let's say this is 5, 2 or 6, 1. If we do this, then we're going to go up here. And these 3 numbers must be for 6, 1. Must either be not 1, could be 2, 3, not 4, and 5. And for this one, 4, 5, 2, it's either going to be 1, 3, 6. Is that correct? Yeah, 1, 3, and 6. If these two numbers, one of these numbers must go up here. One of these numbers must stay here. So if the 2 stays here, this would be 3 and 5, which would come out to 7 here. So that's not possible. Looking here, really the smallest number, the highest number. 3, 5. None of these would work. If you put 5 here, this would be 2, 3, and this would be 10. So really, 2, 3, and 5 does not work, period. Therefore, this does not work at all. 5 and 2, 1, 3, 6. If we put a 1 here, 3, 6 comes out to be a 9. That makes us a 6. That is definitely possible. So I'm just going to note that really this is the only way we can get a 4 out of this. 4, 1, 3, 6, and 9. I'm just going to erase this. At which point we have 1, 6, and 2. So 1, 6, 2 leaves 3, 4, 5. That equals 12. So this equals 12 plus 1. So this is a reasonable construction of these two. So 4 is viable here. I'm going to, before I go any further though, I do want to look and say, let's assume now that this is actually 4 and 2. So if this is 4, if this is a 2, let's clean up the scratch pad a little bit. If this is a 2, how do we get to 7? Well, we can do 1 and 6 or 3 and 4. So 1, 6 or 3 and 4. Go to 1, 6. That is going to leave us with available numbers for the rest is a 3, a 4, and a 5. That's going to be a little wonky. 3 and 4 leaves us with basically 1, 5, 6. Now, like we saw here, where else can we go from here? So if this was, for example, a 6, this would leave us with 1, 5. This would be a 9. So that's not possible. If this was a 5, this would lead us with 1, 6, which is 7, and 8. Not possible. So if this is going to be anything, this would have to be a 1 with 5, 6 here. 5 and 6 minus 15 is going to give us a 4. If we look here now, this is a 3. This is a 4, 5, which is 9. 9 minus 6 is a 6. So the 3 here, 3, 4, 5 leaves us with 6. If we leave the 4, 3, 5, this becomes 8 and 7. So basically, if it's a 1, and we'll sort of do this with a star, just a circle versus a square, just so we can note the difference. This flow will give us a 6. This flow will give us a 1 with a 4. If this is a 4, this would be a 5, 6, and this would be the 4, 5. But look, here we go. So good news, we have a contradiction. So at least we can clear up some of this. The 4s cannot be the same, so I'm going to remove all the circular ones. 4 is out, 5 and 6 is out, therefore 1 is out, therefore 3 and 4 is out. So basically, this is going to either be a 1 or a 3. 1, 6, 4. 1, 6, 4 is going to leave us with 2, 3, 5. 10 plus 3 is 13. So, both good news and bad news. We were able to actually find out that we have sort of two options that work very well in this area. So I guess the question becomes, which one is right? So if we do a quick perusal, one thing I will notice, just as we do this, both of these contain 5s, and both of these contain 6s. So I'm going to just call this a 6, and somewhere here there's a 5, though we don't know where. So I'm not going to be able to put too much here, except knowing that a 5 is somewhere around here. Unfortunately, if we look at these 3 columns, there's not really, this could be a 5. This could be a 5. I mean, this definitely could be a 5. This could be a 5. Yeah, there's no way to sort of find anywhere this might actually live. This 5 might live. Similarly, actually, we both have 3s here as well. So it's really, again, it's really just the 2 and the 4 that are going to be the difference in this. But obviously we have changes there. If we have a 3 here, this must be a 3. 2 and 4. Here has to be a 4. Here has to be a 4. 4, 4. I don't remember if this was we said this couldn't be a 1, so if this is a 4, this would be 4 would have to be 9, which would have to be 3 and 6. So 4, if this was 4, this would be 4, this would be 4. 1 is not possible. If this is a 3, yeah, if this is a 2 or a 3, one of these will not give us the 4 that we need to be guaranteed for us to be able to make the conclusion that this grid has to be 2, 3. And interestingly, I think we'd have the same problem with 2. So where do we go from here? It feels like we've made a lot of progress, but there's no clear moment or way that's to collapse all these options. 6 is here, 6 is here. Without any multiplication, it's really useless to try to put in a 5. Wouldn't it be nice if there was like 10 times? That way we could say, 5 times 2 times 1. 5, 5. One thing I'm going to do here, so I'm going to try this. Maybe this will work, maybe this won't. I see that this is 3 and 6. So this has to be 3 and 6. So I'm going to make an assumption that that is actually what we want. So let's assume for a second that 6 and 3 are true. Where does this take us? So if 6s are here, then 6 has to be here, 2 has to be here, 5 has to be here, 5 has to be here, 2 has to be here. 2 and 3 are out, therefore this is 1 and 4. Therefore this is 2 and 3. 1, 3. What are we at? 1. So we have a 2, 3, 2 and a 4. This has to be the 2. This has to be the 4. This has to be the 4. Oops, sorry. Too quickly. This has to be the 4, and this has to be the 2. This has to be the 4. And this has to be the 1. So 2, 4, and 6. Obviously, this can't be a 4. That doesn't totally help us. Are we getting anywhere? So this can't be a 2. 2 and 3. This has to, if this is the 3, then actually we can just fill in the rest of this now. So we said this was the pink, so 1, 5, 2, I'm just gonna cross that out. 3, the 3 must be here somewhere. So the 3, the 2, the 2, 3 mean that basically nothing here can be 2 or 3. So that would mark out that, giving us 5 or 6 or 4 or 6. Therefore, we got a little bit of an issue here. 6 and 6 don't work so well. Oh, I'm sorry. The 6 is already there. The 6 is already there. This is either going to be a 5 or a 4. And if this is a 5 or a 4, this would be the 2 or the 3, as we've said here. 2 and 3. It's going to be 5 or 4. This, the 1 has to live up here, up somewhere. So this is a 1. So we know that the 1 has to exist somewhere. So let's actually just figure this one out. Which could it be? So if this is 5, then this must be a 2. Then this must be a 3. So if this is a 5, 2, 3, and this would be a 3. That would work. Let's try this. If this is a 4, this then is a 3. This is a 2. 1 plus 2. 3. This is a 4. Ha! Good. Good, good, good. 4, 4, 4, 4. Actually, we already have the 4 here. So this can't be actually. This is just has to be a 5. Therefore, this has to be a 2. This is a 3. If this is a 5, this has to be a 1, which means this has to be a 3. Maybe this, let's not get too ahead of ourselves. Not get too ahead of ourselves. So we have the 2, the 2. Therefore, look at this. 5 and 2 and 5 and 2 don't work. I think we have come to a contradiction. It took a while. Let me just make sure there's 3 and 6. So let's back out of this. So if we're saying 3 and 6, well, let's assume that's incorrect. and 4 and 5. Now, logically, this must be right. I'm going to keep going in orange just because there was a lot of logic we did to get to this contradiction down here, this one. And I never trust myself, so always good to just make sure that we have a big we're making an assumption right here of 4 and 5. So if we look here, we can see that 4 and 5. We have a 5 here, a 5 here, and a 5 here. Therefore, this must be 5. This must be 5. Actually, we just know that this must be 5. Therefore, this has to be 3. If this is 3, this is a completely different route here. Now we have 2. Oh, actually, we still have 2 and 3. Awesome. So, nope. Getting too ahead of myself. This is a 3, therefore this must be 2, 3. Therefore this must be 4 and 1. So if this therefore must be a 4. This must be a 3. 6 and 3 plus 6, 9, 17. That therefore must be the 6 and 3, 6, 6, 12, 15. This must be the 6. So what can be a 6? I'm not sure. There, that was my logic, sorry. 5 and 2, therefore this must be 5 and 2. Therefore this must be 5 and 4. We're doing on the green side now, so this becomes a 3. That seems incorrect. What did we do wrong here? So this is a 4 and 5. This is a 5 and 2, and this is a 5 and 2. This has to be 5. This total has to be 8, so this has to be a 3. What has gone wrong here? Let's think this through for just a moment. Does this have to be a 5 and 2? 5, 2. 11 is 6, 4, 1. 6, 4, 1. It really has to be that. That's a 3. This is a 2. This is a 2. This has to be, to get 7, we said 3 and 4, 1 or 6. Let's just think 3 and 4. Where did we go wrong? We went wrong somewhere. I'm going to back up even more. I want to 3 and 6, 4 and 5. 2, 6, 1. I'm actually going to go back and just recheck my logic here just on the greens to make sure that the green did not have anything. So this could be a 2, 6, 1 or a 3, 4, we said. If this was a 6, 1, 6 and 1 and 2 would 1, 2, 3, 4, 5. A 2, 3, 4 would be a 1, 6, 5. If this is a 3, therefore this is a 4, 5, therefore this is a 6. If this is a 1, therefore this is a 6, 5, this is a 4, which gives us the contradiction there. I don't think we did this wrong. I think this should work. I'll keep this here for a second. We know that this is a 3. This has to be a 6, 4, 1 and a 5, 2. We need to equal 7. Oh, there we go. This doesn't have to be a 5, 2. That's the issue. So if this is a, let's not get too happy and overjoyed with ourselves. If this is a 3, 11 could be 5, 2. If we go 6, 1, 5, 4, 2. So let's try this out. Let's not assume that. Let's say that, actually, let's go back a second. Because we said this is 4, 5, and we said this was 5, 2, this cannot be 5, 2 based on our assumptions. This has to be 6, 1, and this has to be 4, 5, 2. All right, so we're at 6, 1. The 6 is here. This must be a 6. This must be a 6. This must be a 2. This must be a 5. This must be a 5. This must be a 4. And this must be a 3. Beautiful. 1s are gone. So therefore, this must be a 2, 3, which means this must be a 4, 1. This is a 4. This now is going to be 4, 6, 3. If this is a 6 and a 3 and a 6, 9, 15. Therefore, this must be 21. Not to add up, we have to have that to be 21. So it cannot be 3 and 3. It cannot be. Can it be 4 and 2? That's possible. Can it be 5 and 1? Also possible. I believe we said here that this has to be a 1 and a 6. That's 1. This is a 1 and a 6. 1, 1. This cannot be a 1. This can't be a 1. This has to be a 1. Therefore, this has to be a 5. Therefore, this has to be a 2, 4. We have the 4 over here. So 4, 2, 2, 3, 1, 2, 3, 4, 5, 6. 4's here. 4, 6. That's looking good. This feels like we're finally on the right track. Um, let's see. 2 is available. 5, 4. None of these are gonna. Oh, we've actually done most of it. We just have these last ones. So 2, 3, and 5. 2, 3. This must be 5. 3 here. This must be 3. This must be 2. 5, 5, 5. Whew. 2 and 4. So, did we do it? Or is there something weird here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it looks like we actually achieved and finished this one. I really think, to reflect back on this one, the lack of multiplication really was, made this hard. And I would say that there was a lot of sort of counterfactual logic around here. Figuring out this, that we basically had 2 options because of this one, really took a lot to unlock. And it's kind of funny because this is not the most obvious one. It kind of felt like this would be the best way to go through it because you had basically 2 options here. But really, in the end, there's just too many options down here for us to actually understand and make any headway. In the end, we had to go through this a little bit of a convoluted turn. Anyways, that is about it. I'm curious if anyone else has come across this puzzle. If you type in hard KenKen, it's like the second thing that comes up for me. I'd be curious to know any sort of shortcuts because, yeah, I'd be curious to know if there was anything that I could have done that would have sort of sped this up in terms of the process. It's never great to, be going on basically an assumption like this that basically, as we can see, unlocked the entire rest of the grid pretty quickly once we got through that. So, I guess I will sign off now, and I hope you enjoyed watching this video.